Hey guys, today we're going to talk about finding equations of exponential models. So you might have heard the word regression before. Now, a regression is a type of model that best represents the data on a scatter plot. So it kind of gives us an equation to describe how this data is related to each other. So once we have this regression, we can go and predict for different values. So if we interpolate, that is when we make predictions for values that are within the range of data that we were given. So maybe you have a value for 4 and you have a value for 6, but you don't have a value for 5. You can plug in 5 and interpolate. Extrapolating is when you use that model to predict values that are outside or beyond of that range of data given. So beyond range of data. So down here we have how to find exponential models in your graphing calculator. You can click there to find out. I'm about to show you how to do this on Desmos as well. So the one that we're going to try out, this has to do with drunk driving, actually. So in 2007, a university study was published investigating the crash risk of alcohol-impaired driving. The data from over 2,000 crashes were used to measure the association of a person's blood alcohol level with the risk of being in an accident. And then there's a table. So we have the blood alcohol level here and the relative risk of crashing. So the risk of crashing we'll just call 1 if you don't have any alcohol in your system, and then you can see from there. So what we would like to do is we'd like to be able to put this table into our calculator. So let's go ahead and find our graphing calculator. Here he is. Okay. So when you're inside of Desmos, and you click that guy. So we need to put in that table, right? So we're going to press plus, and then we're going to click on table. And then we can start putting those values in, 0 and 1. And then we had 0.01 and 1.03. Okay, I'm going to put the rest of these in and meet you in a minute. So now we've got this data in there. We know it's going to be exponential because stuff got really big, really, really fast. Also, it's the exponentials unit. So here's how Desmos does this. We're going to have y and then 1. Then we need a tilde. And then remember, exponentials is ab to the x, right? So I'm going to have ab, and I'm going to do my caret to get that exponent, and I'm going to have x, and then 1. So that way it knows I'm referencing x1 and y1 from right above. Log mode right here, we'll move that into a log. You can have it as a natural log, things like that. Okay, so we can see right here, r squared is 0.993. That is really stinking close to 1, which means that it is a really, really good model, right? So it says that A is equal to 0.382, blah, 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 and B is equal to that junk times 10 to the negative 11th. Now that's a little bit gross, but we can handle it, all right? So let's pop back over here. So that A value right here was 0.3824, and then our B value was that, let me pop back, sorry, 3.467 times 10 to the 11th to the x power. Boop. So we just popped in those numbers for A and for B. So using the model from A, interpolate the relative risk of crashing when you have a blood alcohol level of 0.08. The reason I picked that was because 0.08 is the legal limit for somebody over the age of 21. Remember, the legal limit for anyone under the age of 21 is 0, right? Because you're not supposed to be drinking. All right, so let's take a look at this. What we'll do, remember, y will be my risk of crashing. Then I got 0.03824. I have 3.467 times 10 to the 11th to the, and remember my X value is that blood alcohol level, so that's going to be 0.08. So then we'll put that into our calculator. Okay, so we've got 0.3824 times 3.467. Where's the times 10? And then we're going to go second and then log, because that's where we have the, oopsies, I should put times. And then we're going to go to log. We're going to put 11. Cool. Close that. And then that will be to the 0.08 power. We'll press enter. So we end up with about 3.2. So my risk of crashing compared to if I wasn't drinking at all, I am 3.2 times more likely to get in a crash if I am at the legal limit than if I haven't drank anything at all. Now let's extrapolate. So first of all, I can't even imagine how someone would still be alive at like 0.12. Right? Like if your blood alcohol level is like that, that's crazy. So now let's just extrapolate to something crazy at like 0.5. Okay. So we are going to use our calculator again. Since I don't want to type that whole thing out again, I'm just going to put second and then enter. And then it'll put the exact same equation in there for me. But I'm actually going to, here we go, change that decimal. So I just need that as 0.5 now. Get rid of that 8. There we go, 0.5. And then we'll press enter. Okay, so if somebody has the ungodly blood alcohol level of 0.5, they are 225,161.8 times more likely to get into a crash, right? Because I mean, my goodness, they must be incapacitated by that point, right? So obviously they would have to get into a crash. All right, so that's how we find exponential models on Desmos, and that's how we interpolate and extrapolate. See you guys later.